Hello everybody, my name is Alex. In today's video we're going to be continuing on with the VR shooter template for Unreal Engine. So in this video I wanted to focus on getting in some of the movement controls for the player. For this one we'll be doing locomotion rather than teleport or anything like that. There are reasons behind that and I will explain it as we go on in the video. But before you go and jump into that, be sure to like and subscribe. It helps out a ton. And with that, let's go and jump right into the video. All right, so here we are. We are in the VR shooter template. I've already gone ahead and opened it up, as you can see. I'm going to clear that. So let's go ahead and start off by opening up the motion controller pawn. Is where we'll start. Now I want to go over real quick why it is too we will be using locomotion movement as opposed to teleportation or anything like that. While teleportation tends to be a lot better for a lot of circumstances if it's an option, when you're doing something like a shooter, it's typically a little bit better if you do locomotion movement because it one helps out a little bit more with the realism, and two, it means that people can't just be teleporting all over the place, making it difficult for people to get shot or shoot at other people. So it's just a overall much better means of movement when you're doing shooters in most circumstances, at least. There are certainly areas where teleportation might be a little bit better, or where it can be implemented in a way where it works really well. But in most cases, you're typically going to want to just have straight up locomotion movement or a combination of locomotion along with teleportation. Which is why, as I said, locomotion is what we'll be focusing on for this video. Alright, so since I already have this open, in case you are unaware, I'm in the event graph of the motion controller pawn. And before we do anything, we need to first have a look at our inputs. So in order to actually be able to move around, we will need to be able to trigger it using, of course, analog sticks on our motion controllers. As far as I'm aware, every motion controller that comes with the VR headset has some form of analog or touch input or something like that. I'm using an Oculus, so mine's analog. So yeah, so we can actually see over here, we have our teleport left and our teleport right. Now if I recall correctly, let me go ahead and open up the project settings so we can have a look at this. And we have a look at our input. If I recall, our teleportation is actually handled. No, it is tied to the action. Okay, so I thought it might have been tied to our axis, but it is not. So there's actually a difference between action and axis mappings. So action mappings are typically bound to button presses because it's basically meant to have either a on or off state, pressed or not pressed. You can see that actually for the teleport, it actually does use the thumbstick on the right and left, which this should be if you actually press it down, if I recall. But if we actually look over here, you can also see we do have separate bindings in our axis mappings for motion controller thumb left Y and X, and as well as thumb right Y and X. Now, the difference, what's important to understand about the axis mappings is that unlike action, your output will range from typically -1 to +1, depending on what it is you're using. So this will actually allow for us, so if we take the left for example, you can actually see we have right here thumb left and thumb Y. So this is actually bound to how far we're moving our analog stick on the left motion controller. So for example, x is going to be your left and right, right being +1, and left being -1, and then your y is going to be your up and your down, up being +1 and down being -1. And then right in the center you're going to have 0 or at least close to it. If you're suffering from something like stick drift or something like that, then maybe you won't get to exactly 0 on the x and y. So that may be something you want to account for later on, having a sort of dead zone somewhere in the middle that players can adjust. So going into here, I'm actually going to disable the teleport for now, but I'll leave the code in, just because you never know if maybe later on you're going to need it. But I'm going to go and remove it. Now let me go and double check here, because if I recall, we're not actually using the axis mappings right now, but I just want to double check. Yes, we are not. Okay. In that case, we will be using the axis mappings from the input. So I'm going to keep this open so that way we can refer to this right now. Motion controller thumb left and thumb right. So we can actually go and pull this up. Thumb left. There we go. Let's go and pull. Actually, let's go and have a quick look at this. So I actually want to bring up again like differences between action versus axis mappings. So if you actually look, this is an action mapping, and this is what. This is an action mapping, and this is an axis mapping. So you can actually see there's a few different methods for controlling the flow of how things come out of the action and the axis mappings. So on action, you actually have pressed, release, and then you also have key. Key, if I recall correctly at least, refers to whatever key is being pressed. So if you actually look at action mappings, you can actually see that you can have a number of different possible outputs, which is why you actually have key. For example, if you had on your keyboard, you had 2 or 3 different buttons that all did the same thing, you could actually detect and see what key is specifically being pressed. Which typically isn't how you're going to use action mappings, but I'm sure there's a reason for that somewhere out there. You can also see that in action mapping you have pressed and released. Both are fairly self-explanatory. So if we were to use it, for example, on a trigger, you'd have your press and you'd have your released. Release doesn't actually happen at the very beginning, so you don't really need to worry about that. It will only happen whenever you release it after being pressed. Press has to be done first. If you look at the axis mapping, it's a little bit simpler, more straightforward. You can see you have the axis value, which, like I said, will typically range from -1 to 1, depending on what you're controlling. That's at the release with an analog stick. Other buttons you might get between 0 and 1 or 0 and -1, depending also on how you set up your scale. That may change. And you can also see you only have one output for flow control in Blueprint. So it's a little bit more straightforward, but we will need to do a little bit more math later on to actually get this working. Now let me go ahead real quick. Not input access, my bad. Motion controller thumb left. So we'll want to grab Y. And then we're also going to want to grab the same for, I don't know why I keep putting input access. Motion controller thumb right, X and Y. There we go. And motion controller thumb right, Y. All right. And in case you weren't paying attention in there too, you also have, let me go ahead and bring this up. You also have axis values, which is just straightforward, the axis value that you would be getting otherwise here. So it's basically the same as this, just without any execution node that's coming out of the function. It's literally just whatever the value is. Which I'm sure is useful if you're trying to do it somewhere else in, say, the event graph or something like that. All right, so now that we have our input axes axis is xi. I'm not going to bother with what is technically correct. It might be xi. I'm honestly not sure. But anyways, now that we have this in our event graph, our motion controller thumb left for x and y and our thumb right x and y, at this point we kind of need to determine how we want to move. Now there's a number of different ways to go about doing this, and it's quite frankly going to depend on a lot of things, depending on your parent class, for example. It's going to depend on whether or not you're going up or down slopes, because certain methods will work a little bit better. You have a bunch of different options at this point. Since we're a pawn, there's really one very simple option though that we can use, and that's going to be add movement input. Now this it's pretty straightforward. It's essentially going to be we're going to be adding a movement input. So let's actually go and run down this. So first off, let's go ahead and attach our run node here. Next, if we actually run down here, we also have our target, which is going to be ourself, because that's what we're causing to move. And you can also see too, you do have to make sure this does have to be a pawn. This isn't going to work with a character or something like that. It has to be a pawn. The other things we have here are roll direction, scale value, and force. Force I'm not going to bother with. I'm just going to leave it false. Quite frankly, I don't want to worry about that right now. But I do want to look here at our roll direction and our scale value. So starting with our roll direction is going to be whatever direction we want to be moving in. So in this case, we're actually looking at our x value. So just quick reminder here, if we look at the thumbstick, x is going to be left and right here. So this is going to be, do we want to move left or do we want to move right? How fast? Things like that. So if we actually go ahead, we can actually, this is actually another thing too, is how you want to move. And what I mean by this is you have a lot of different things you can base it off of. You can base it off of, for example, what direction your hand is facing, which is commonly used in VR. However, personally, I hate that method. You could move based off of your headset, whatever direction you're facing. That'll determine what your left, right, forward, and back are, which is personally what I prefer. Or maybe depending on your setup, maybe you have some other methods and you want to give the player like a little bit more choice in what direction they want to move in. So, trackers, for example, things like that. I, quite frankly, though, don't know why you would ever want to do that. I think that would honestly be a very terrible choice. But, I'm sure that there would be a reason that would work in some VR genre game or something like that. Anyways, so because I want to keep this simple and because personally I prefer camera over what direction my hand's moving, I'm actually going to base this off of the direction that our headset is facing. So in this case, it's going to be camera in our motion controller pawn. So, like I said, this is going to be our left and our right. So, in order to actually determine where our left and right is in world direction, or world space, I guess I should say, we're actually going to want to get the right vector. Now, what is the right vector, in case you're unaware? The right vector is actually what is considered your right based off of that component. So, in this case, this is my right. On screen, I think it might look like this. But so let's say I'm facing this direction. That means our right vector is now going to be this direction in whatever the world space is. If I'm facing this direction, it's going to be right in this direction. So it's always going to be relative to what that component is, but it's going to be converted into world space. which is again something else we want as well. World direction, when you're working with VR, it tends to be a little bit easier than if you're working with relative, just because in VR typically you have a lot of moving components to the player, so relative can get a little bit messy. But anyways, so we have then our right vector, which we're going to use to determine where our right and left is. For scale value, we're going to pass in axis value. Now this will probably have to be manipulated at some point in order to make it so that way we'll move either faster or slower. I'm going to leave it at what it is for now, although it's probably not going to be noticeable, and I will come back at the end and see what is a more fitting value. But this is going to be how fast do we want to move in this direction. And you can also see too when you're reading it, -1 will automatically become a reverse of whatever direction it is we're facing. So when we move our analog stick to left, we will actually move, even though we're saying this is the direction we want to go in, -1 is telling us we actually want to go in the opposite of this direction. So we'll actually end up moving this way instead. So it's fairly simple, fairly straightforward. And then we're also going to want to do this for the Y. Now this is actually going to be a little bit different actually. So let me go ahead and set these up real quick. Grab our camera. Okay. Now in this case we clearly don't want to grab our right vector. The reason being is that we don't want, when we move up and down on our analog stick, we don't want to move right and left still. We actually want to move forward and back. So there's another vector that we can use for this, and that's going to be get forward vector. It's essentially a similar thing to what get right vector is, except rather than taking our right, we're actually getting whatever's in front of us, or forward. Now this is actually going to, depending on what it is you're attaching this to, I think most components that have a world space or a relative space have a forward and right vector. So like static meshes and stuff have this same thing if you chose to use your hand or whatever. But it might be a little bit weird depending on what it is you're trying to get the forward and right vector for. So for example, static mesh might be kind of weird if you have that on a hand. I believe by default the forward is actually set to forward, but I don't believe, I may be wrong, but I don't believe that right on the hand is actually right. At least on both hands. I think at least one of them is wrong. But anyways, now we get over here to the thumb right. Now this again kind of comes back to personal preference based off how you want the game to play or how the player wants to move in the game. At this point, we actually aren't going to want to do anything with the Y. The Y is actually kind of useless on the right thumbstick for what we're going to try and do. We do want to focus on the X though. Now depending on the player or your style, maybe you want to use the right instead or in addition for movement. However, we're not going to do that. We actually want to use the right in order to rotate. So we're actually going to use this actually to rotate our player around, which kind of leaves our forward and back or our Y value kind of useless in this scenario because we really don't have anything that's sensible that we can bind to that aside from maybe teleportation. So we're only going to be worrying about the X, and I'm actually going to delete the Y for now. Okay. So in order to actually rotate, we actually want to, let's see here. If I recall, there's actually a couple different ways we can go about doing this. We use add actor world rotation. So let's go and grab this. All right. Sweep and teleport. These are kind of going to be based off of how exactly your player is functioning at the moment. I'm not really going to worry about these right now. I'm just going to leave that there. Okay. So we're going to leave that like that for a second. What we do need to manipulate, though, is our rotation. So if we actually go ahead, let's actually have a look at our player real quick. Here's our player. So in order to actually change our rotation, we want to change the root of our actor, or what will be our actor itself, since the root technically is kind of considered the actor since it manipulates everything. Um, so in order to actually determine what direction we want to move in, um, we can actually have a look at this. So you can actually see, for example, if we change our rotation to X, that'll actually start flipping us around, which isn't what we want. Y, if our call goes up, forward and back, which again isn't what we want. But what we do want is we do want to be able to manipulate our Z, since this will actually turn us left and right. So if we actually go ahead and, like we saw there, now we know what it is we want to actually manipulate in order to actually rotate around. So that gives us a nice little idea of what we're trying to manipulate here. So we can actually go ahead. I'm actually going to, where is it? Where is, there it is, split struck pin. So we can actually use this to actually manipulate our rotation. Now, because we're manipulating this in World 2, we probably honestly could have manipulated relative, but World tends to work a little bit better. So we can actually use this with the axis value, plug that into our Z, and this will rotate us left and right. So fairly straightforward, fairly simple. We don't really need to worry about the X and Y since we don't want to manipulate those rotation values. We don't want to move forward and back or, left and right like that. So yeah, so that kind of leaves that pretty much done. Again, we will come back to this and add in some manipulations. That way we can increase the speed at which we rotate. But we'll give this a shot first and see how well this works real quick. I didn't have to make too many changes to the blueprint that was already added in. However, there are some issues that I did want to bring up, especially when incorporating VR into this whole movement, into locomotion movement, and to be specific. The main limitation with using a pawn specifically is movement. Movement tends to be a little bit weird, especially with a VR pawn. So actually looking at this, we have, I actually attached a floating pawn movement, which creates some issues that I will get into in a sec. But aside from that, I've also increased the scale value by 50 by simply adding a multiply by float and then setting the constant to 50 and then just attaching that to the scale value. This will make it so we move at a slightly faster pace. Now going back to the issue that the movement component, so in case you're unaware, this I actually added in because this is actually required in order to actually get the add movement input to function. The issue, however, with this is that this is a floating pawn movement, which means that we actually don't have any sort of gravity or anything like that, which creates a bit of an issue because that means that when we actually jump into here, like if I go and show you real quick, so let's go and jump in here so I can show you. So first off, right off the bat, rotation works pretty well. It probably could use an increase in speed. However, you do want to be careful with how fast you do any sort of movement like this, where the player themselves isn't moving, because it can be a little bit nauseating for some players, or just a little bit disorienting in general. So I just left it at the at what it was because I thought it was good enough. But when we actually look at the movement, so you can actually see it does move based off the headset, and you can see it actually moves in all directions quite well. The issue becomes, however, as you can see, is that there's no gravity or anything like that that is actually attached to the floating movement component. Which, I mean, I guess this makes for a really great spectator cam. You know, that this works really well for something like that. However, this isn't ideal for when you're in a game. Now, actually, looking through the components that we actually have for the pawn, we actually don't have a lot that are very VR friendly. Um, so you can actually see these are the ones that we have. Clearly, we don't need a projectile. And we don't need rotating. Those projectiles kind of useless in this situation. Rotating, we kind of already have handled. Which means that we're kind of left with having to simulate physics through a different method. Um, Now, this isn't really an easy thing to cover, especially since I have no idea how long I've taken on this video so far. So this is actually something I'll have to come back in the future. As I've already said, later on down the line, I do plan to do it, to go back to some of these older videos and basically do like just a bug breakdown, see things that should have been done differently, and or things that just in general need to be fixed. So I'll definitely be coming back to this in the future so that way we can implement gravity into this manually through Blueprint. Because this will take a little bit in order to actually make it look well. So we'll go and leave this as it is for now. And we'll definitely have to come back to this in the future so that way we can actually add that gravity. But in terms of functionality, this adds the functionality that we need. In terms of where the the shooter template is right now, this is a good point to just kind of leave it for the moment, and since it serves its purpose well enough for the time being. So yeah, there's that. Like I said, gravity definitely will need to be implemented at some point in the future. However, that will likely have to be done manually. And as I said, I also mentioned this in the last video. I definitely do want to come back and do little bits of bug fixes and things like that, and just kind of improve things that maybe I should have done a little bit differently to begin with, anyways. This entire project is actually all a bit of work in progress, and I'll actually be leaving a link in case you want to check out this template in the description below. I've actually made a GitHub repository for this in the hopes that this will actually become useful as a proper shooter template in the future. But yeah, so like I said, this will definitely be improved upon over time. So with that, that's the end of the video. So yeah, all right.